Could your limbs have evolved from fish gills? While it might sound a bit fishy, scientists from the University of Cambridge have discovered that the same genetic program, triggered by a gene called sonic hedgehog, yes, really, is involved in the development of limbs, fins, and gills. The idea that the formation of gills and legs might be linked is actually not a new one and was first proposed more than a century ago based on the similarities in appearances of the two structures. But scientists abandoned the notion as fanciful thinking. Connie Orbach went to see researcher Andrew Gillis, who has discovered that this idea has legs, after all.
Nearly 150 years ago now, there was a theory put forward by the comparative anatomist Carl Gegenbauer that perhaps paired appendages, so fins and limbs, may have evolved from gill arches, from the skeleton of the gill structure of fishes.
The gills of fish, I think, have been quite floppy. You're talking about a particular type of fish, aren't you?
That's right, yeah. These are the cartilaginous fishes. So this is a group of fishes that includes the sharks and skates and stingrays.
How did he come up with this idea?
He noticed that the way that the branchial rays, these little cartilaginous rods, stick off of the gill skeleton is very reminiscent of the way that our limbs and fish fins stick off of the shoulder, or the fish equivalent of a shoulder. He proposed, based on these similarities, that perhaps these different kinds of appendages were built on a common plan, and that there was sort of a common underlying pattern that could be recognized in both of these different kinds of appendages.
He basically just went, looks kind of familiar. So we're in your lab right now, and in front of us is a dish with, I've got to say, really beautiful looking fish in here. What am I looking at?
So this is basically a skeletal preparation of a very late stage skate embryo. So this is an embryo that would have been about to hatch. It's quite large. It's probably about 10 centimeters from front to back and about maybe 4 to 5 centimeters across in wingspan. And this embryo has been cleared away with chemicals and stained with particular dyes that label the elements of the skeleton. And so what you're seeing in blue here is all of the cartilage, and what you're seeing in pink is the mineralized tissue. So they don't have bone, but they still have a sort of a layer of mineral that reinforces some parts of their skeleton.
Where are these gill arches on this specimen here?
They're sticking off the sides of the head here between the skull and the inside of the big wing of these animals. So you can see the eyes in the front of the specimen sitting on top of this cartilaginous brain case, and a spine going down the middle. And then sticking off on either side of the brain case are these little branchial rays, these cartilaginous rods. And they originate on these large rods of cartilage called the gill arches that sit just underneath the brain case.
They're just fanning out from the back of the head there. Not very long, but there's around 4 on each side, and you can definitely see that they're cartilage. They look quite stiff. I guess if I push myself, I can see some sort of finger-like, limb-like thing, but how did the rest of the world take it?
At the time, I think it was considered to be a reasonable possibility by his colleagues, but over time, as the fossil record failed to support this hypothesis, it was largely viewed as discredited and wrong, really, and the idea really kind of fell by the wayside.
Until today, right? Or until now, because you have given us a bit more of a connection.
We were interested in testing whether or not these similarities reflect any common underlying molecular mechanisms. We started off by looking at the role of a particular gene called sonic hedgehog that's important for the development of limbs and fins. We demonstrated that sure enough, this gene is expressed in the developing gill arch appendages of cartilaginous fishes. And when you turn this gene off at different times in development, it actually functions in a way that's very similar to the way that it functions in the developing limb.
Just because there's a similarity doesn't mean one came from the other, right?
That's true. In a sense, what we're trying to do is uncover the genetic network, really, that controls the development of these gill arch appendages. And if there are additional similarities, if we find additional complex genetic interactions that are shared, then that might build a stronger case for there being perhaps an ancient developmental program that's been conserved in evolution and used to build different kinds of appendages. Alternatively, it could be that gill arch appendages and fins and limbs are built in completely different ways, and they just happen to coincidentally use one or two of the same genes. And hopefully we'll be able to tell which of these two situations is the case.
Aptly named Dr. Andrew Gillis from the University of Cambridge, and that paper was published in the journal Development.